Running in parallel with the stretch reflex is a protective counterpart called the inverse stretch reflex. This circuit involves the Golgi tendon organ, a receptor at the junction between muscle and tendon that monitors tension rather than length. When muscle tension becomes very high, the Golgi tendon organ fires signals through IB afferent fibers into the spinal cord. Those IB fibers activate inhibitory interneurons, which release the inhibitory neurotransmitter glycine onto the motor neurons. Glycine hyperpolarizes the motor neuron, making it harder to fire, which causes the muscle to relax. This is a protective mechanism that prevents excessive tension from tearing the muscle or rupturing the tendon. With very strong stretch, the resulting hyperpolarization of the motor neuron can become so great that it stops firing entirely. This is precisely the inverse stretch reflex in action, a complete inhibitory override triggered by extreme tension. What makes both of these reflex circuits even more sophisticated is that they are not fixed. They are continuously modulated by descending signals from higher brain centers. Both alpha motor neurons and gamma motor neurons are subject to this descending regulation. By adjusting gamma motor neuron activity, the brain can preset the sensitivity of the muscle spindle before a movement even begins, essentially tuning how hair-trigger the stretch reflex will be. This is why upper motor neuron lesions, which remove inhibitory descending control, cause hyperreflexia. The reflex gain is turned up with no brakes applied. Lower motor neuron damage abolishes the reflex entirely because the output pathway is severed. In summary, the Golgi tendon organ lies at the musculotendinous junction, is arranged in series with muscle fibers and tendon, and primarily senses muscle tension rather than muscle length. Its most commonly discussed role is inhibition of muscle force production when load becomes excessive, although it can also facilitate or inhibit contraction depending on spinal and supraspinal influences. Deep tendon reflexes, DTR, are classic muscle stretch reflexes. Stretch receptor activation sends afferent input to the spinal cord and generates a simple monosynaptic reflex arc with direct alpha motor neuron activation and muscle contraction. A comparable protective, unloading response is described in jaw muscles. Sudden unloading reduces muscle spindle afferent activity, producing a silent period in jaw-closing muscles that limits excessive force. Routine neurologic examination sources discuss muscle stretch reflexes, their grading, symmetry, and changes in upper versus lower motor neuron disorders, but they do not describe the inverse stretch reflex as a standard bedside test. In the next video, we will go over the neuromuscular junction, its structure and components.